Cool, so my name's Joe. I've been at AZTEC for about just under 2 years. So I lead our kind of product and developer outreach. We figure out how we can get developers building on AZTEC on Ethereum. Before that, I was in the US for about 3 or 4 years as CTO of a food tech company, Radish. I'm actually an Imperial alumni as well, so it's good to kind of be back here. All those years ago, I left in about 2013, so that's me. So yeah, I think first of all, it's just good to define what a security token is. We've had the kind of ICO boom where people have built utility tokens, and I think the next wave of Ethereum is actually going to be around security tokens. So let's just look at what those are. I define them as an on-chain representation of an income-bearing asset. So if you compare that to a utility token is awarded as an incentive for doing something, some sort of work or utility on a platform, whereas a security token is bought or sold based on its ability to bear income in the future. So it's actually a real asset as opposed to a way of avoiding securities laws. And as such, the underlying asset is exactly the same. It needs to obey the same regulatory requirements as a bond in the traditional markets or an equity or a loan. So it's not a way of escaping UK or US regulation. It has to obey the same regulations. And in this case, the point of the blockchain is to encode the token in such a way that the transaction logic and settlement are guaranteed ahead of time, and you don't need to go to court to enforce it. The blockchain will enforce it, and it's kind of preordained what's going to happen. So if we compare where we are in kind of traditional financial services and kind of what's possible today, they offer privacy by default. So if I'm a company with $20 to $50 million of revenue, I can go and raise a term loan B. I can go to an arranging bank. I can arrange a form of credit that will be private by default. The bank will be forced to sign a confidentiality agreement, and they'll go out to a group of lenders and raise a form of financing. The only people who can see what's going on in that transaction are the counterparties to it. It's not broadcast to me and you or the public. So if we're going to have a chance of moving those on chain, we have to kind of solve privacy. So we're going to go into that in a bit more detail later on with some examples. These are kind of examples of security tokens that we hope are going to get built in the coming years on Ethereum. So just traditional financial assets. So this is where we start to get a little bit more technical, but it should be kind of commonplace for most people in the room, but it's just worth reiterating that whenever you do a transaction on a blockchain, the inputs and outputs to the transaction are public, and the logic of the transaction is also public. So if we want to do something like this if statement in a regulated asset, there may be a regulatory requirement for a bank to only own 4% of a particular asset because that's the law in a certain jurisdiction. So in a normal Solidity contract, that's fairly simple. You can pass in the trade notional, and you can look up the buyer's balance, and you can do a check to ensure that the post-trade balance is not going to be greater than the regulatory max. In the process, though, you reveal both the trade size and the buyer's balance, which historically has limited most real-world assets from coming on chain because that's just a non-starter. So we take the view that privacy is a prerequisite for building security tokens. You can't build a security token unless it's private, because the only collateral or the only assets that you'll be able to use in such a token are non-real-world assets. They're kind of Ethereum or DAI, or things that have originated on-chain, and we think the bigger opportunity is taking current old off-chain assets and putting them on-chain, which means you're going to need privacy from the get-go. So yeah, just reiterating what I said, we must give loans, bonds, equities the same level of privacy they currently enjoy when you go to a bank to originate these products on-chain. So that's kind of the point of this talk, to help everyone in the room figure out how we get started doing that. So if we go back to our previous example, all AZTEC at a high level enables is the inputs and outputs of a transaction to be private. So if we compare the public Solidity version at the bottom with the top, we've replaced the inputs in the transaction with a zero-knowledge proof. There's a family of zero-knowledge proofs that AZTEC has, which I'm going to go through in a bit more detail in a minute. But the basic idea is, instead of passing public variables into a smart contract, you prove away from the blockchain, you construct a proof away from the blockchain that proves a certain logical statement, and you send that as the input to your smart contract, and the result is exactly the same. So in this example here, we can prove in this proof data that the trade notional and the asset balance is either greater than or less than the regulatory max, and based on if it's based on the outcome of that proof, we can either allow the trade to proceed or reject it. So the coding is the same, it's just kind of thinking a little bit more carefully about what we're sending to the blockchain, and we have to kind of construct these proofs ahead of time in the user experience, in the UI. So,
what's the difference between a private range proof and the proof data?
In this example here, we have about 8 different proofs that you can currently use in AZTEC, and this just is the ID of a proof. Okay. So we have a private range, public range, swaps, dividend proofs. So you basically it's just a way of selecting inside AZTEC which proof you want to call. You can kind of think about it as like a private calculator on-chain that will say yes or no based on the outputs of the proof.
Selection.
Yep. So, just a little bit more detail about what those proofs are. As you saw in that example, we have the range proof. AZTEC works on the concept of notes. A note is a bit like a Bitcoin UTXO. So it's basically a form of encrypted value. And all of our proofs prove something about those notes. So in the case of a range proof, you want to prove that one AZTEC note is greater than or less than another AZTEC note, which is the same as an inequality in public code. It's fairly useful for proving ownership notionals and just transaction semantics around voting or majorities. So if you have an asset where you may need all owners who own above 15% to sign off on a certain type of transaction, you can kind of code that in AZTEC without revealing people's actual balances. The next one is a swap proof. This allows us to do trading in a decentralized manner. So if you have one AZTEC asset that represents a loan, when you want to settle that asset, you can settle it with a form of zero-knowledge currency, so on-chain stable currency, such as USDC, DAI, whatever currency you choose. And you can effectively, at primary settlement of a loan or a bond, you can swap the loan security tokens for an asset that represents stable currency at a fixed price, and you won't reveal how much was paid for the asset or how much the asset a particular account bought. So this is useful for primaries and also trading in the secondary markets. The next one is a send proof, which is more useful for just generic payments on-chain, or if you're dispersing interest payments or you have an asset that's kind of trying to disperse cash flows. The send proof is how you actually send out a form of zero-knowledge stablecoin. A mint and burn proof, so when we originate assets, say you have a credit agreement that has a revolver in it, you may want to mint a portion of a loan on demand. This will create new security tokens that represent the loan, or you may want to burn them when a loan expires or matures. So you can code up quite a lot of different semantics in a smart contract using these proofs. And the last one, which is I think the most interesting, is the dividend proof. So if you have an asset that represents an income stream, one of the main things you want to do, and that makes it a security token, is pay out income that arises from that asset to the end holders of the asset. And to do that privately, you need to be able to pay it out in the ratio of their ownership, but without revealing what their ownership is. So We use this in the loan example, which we're going to go through in a minute, to disperse income payments that arise from loan interest to the lender of the loan without revealing what their holding of the loan is. So in reality, what you're proving is one AZTEC note is a ratio of another AZTEC note, and that ratio is the interest rate.
What's the difference between send proof and range proof?
Sorry,
Send
can you
on.
use the microphone, please? Because we don't hear a question. Thank you.
When I was back in the time looking at AZTEC, I remember that somewhere on the website says that you are using range proofs for transactions. So what's the difference between here, in your categories, between send proof and a range proof?
Yep. So all of these under the hood use our generic AZTEC range proof. The range proof here does two things. The first thing is you have to prove that an AZTEC note doesn't wrap around the elliptic curve modulus. So if you have an AZTEC note that represents 10 and another one that represents 1, and you're trying to do a transaction, what AZTEC's doing on chain is validating that 10 minus 1 equals 9. The quirk of elliptic curve arithmetic is that if you put a minus 1 into that equation, it can't tell the difference. So the result on chain is that you'll have ended up printing more money than exists in the universe. So the first thing that a range proof does in all of these transactions is to check that no note has a negative value. So we do a range proof that proves that all of the notes in question are between 0 and the maximum value, which is allowed inside AZTEC, which is going to be about 100 million in the first iteration. So they all use the range proof. Then there's like another iteration of the range proof which allows you to use it for your own custom semantics. So you can prove that one AZTEC note is greater than or less than another AZTEC note, and you'll also prove in the process that they're both inside the range. Does that make sense? Mm-hmm. Cool. So why does AZTEC exist, I think, is a good anecdote. So we didn't set out to build a privacy platform on Ethereum. We originally set out to build a loan origination platform called Credit Mint. The goal here was to kind of make a debt origination platform that was very familiar to the capital markets, but used Ethereum to settle loans trustlessly and remove counterparty credit risk and speed up settlement in the secondary markets. We realized in 2017 that privacy wasn't going to come to Ethereum for a long time. It was meant to come at the Byzantine hard fork, and it never did. And our CTO Zach set out to build what then was just called AZTEC. It was just a paper that we were going to use to underpin our own privacy for the Credit Mint platform. We then realized in about November that the use cases for this kind of were more far-reaching than just credit, and it could be applied to bonds, payments, all manner of kind of traditional banking activities. So we pivoted the company slightly to be a privacy protocol, helping other people do what Credit Mint was trying to do. So it's actually was designed for debt issuance and building security tokens in the first place. So that's how it came to be. So just a quick recap of what is AZTEC, and then we'll get into some coding and some demos. So AZTEC is, in our heads, an interoperable privacy network. If you compare AZTEC to a technology like ZK Snarks, ZK Snarks work in kind of closed silos. So one ZK Snark-based dApp can't talk to another ZK Snark-based dApp. With AZTEC, all AZTEC assets can communicate with one another, and you can prove something about one AZTEC asset in, say, a loan origination platform. You can prove that to another bond platform, which means you don't get siloed capital. So you can use the funds that we use to settle a bond trade can also be used to originate a loan trade, which is one of the big benefits of a public network, is all your capital is fungible with any other asset on the network. So that was very important when we were designing AZTEC. And the second point, which I think is will apply to most of you in the room, is it's a toolbox that allows developers to, without a cryptographer, build these private assets. We don't think that you're going to get banks or kind of new Web3 startups all hiring their own cryptographers because it's a very hard skill and there's simply not enough of them. And if everyone had to roll their own cryptography to get assets on chain, I think the iteration cycle and the progress, it would just take far too long to get there. So the goal of AZTEC is to have a trusted set of cryptography that's been peer-reviewed, validated, and audited, and allow other people to use that in a composable way. And it's also extremely gas efficient. So currently it's about 800,000 gas to run a standard AZTEC transaction. And this will go down to 200,000 gas at the Istanbul hard fork. To put that into context, 800,000 gas at today's prices is about $1. So it will go down to about 20 to 30 cents at the next hard fork, which is a lot if you're sending $10 of payments, but if you're originating a $10 to $20 million loan, it pales into insignificance compared to fees that banks charge today. So let's get into a demo. If you want to follow, I'm going to do a demo first, but if you want to kind of follow along, if you head to our GitHub, AZTEC protocol, there's a project called the Loan DApp Starter Kit, which you should be able to clone, and it will take a while to install the dependencies. So if you want to kind of run through these steps whilst I'm doing the demo, I'll do the demo and then we can have a kind of Q&A on what's actually happening here, and hopefully everyone else at that time will then have this set up and running on your computers. So does anyone have any questions so far, or is that? Can you grab the microphone? I'm not sure what.
Could you please pass the microphone?
Thank you. My question is, how does AZTEC make money in all of this? This is kind of an open source toolkit or protocol, or even, I suppose, an execution environment with a consistent, trusted setup to run all of this stuff. How do you monetize?
So we charge a per transaction fee. So in that proof, in the example I gave of 800,000 gas, we have a gas multiplier. So every time you want to validate a proof, you pay 1 times gas to the miners, they validate the proof, and you also pay the same to us. So we don't take any view on what the asset is going across it. We can't even tell, but we just charge a per transaction fee. So we're incentivized to get more volume through the system and create a greater pool of liquidity by having this single place on chain where proofs are validated.
And I suppose the defensibility of that fee is largely in the network effects of...
Yeah, the fact that all assets can communicate with each other means that if you decide to fork the open source smart contracts, 2 things will happen. One, you'll have a smaller kind of liquidity pool to actually buy and sell zero knowledge assets out of, and the second is you won't get any updates obviously to the proofs. Like we have 8 proofs today, but we're going to have much more in the future that would do a lot more complicated things like derivatives and stuff, so you won't get access to kind of updates.
Yeah, but
thanks.
The proving engine, is it possible to update the proving engine?
Yep.
Could you repeat again question for...
So the question is if it's possible to update the already deployed verification engine.
Yeah, I can run through that if that would be helpful. So we have this is kind of what the setup looks like on chain. So a ZK asset could be a stable currency, it could be a security token like a loan. It's just anything that uses AZTEC, and it talks to on-chain what we call ACE, which is our cryptography engine. And that cryptography engine has a set of validators, and these validators are the actual contracts which validate proofs. So the whole system is modular. So over time, right now, this is our send proof, this is the swap proof, this is the mint proof, private range proof, etc. If we add new proofs or different versions of the proof, we can simply upgrade them. And it's up to the asset owner, so in this case, the developer, to select which proofs they want to use from the engine. So everything's fully upgradable and is designed to kind of allow you to constantly have up-to-date assets using the latest proofs as we innovate with new proofs. Cool. So let's dive into what's possible. So I've got two accounts here. We'll treat the right-hand side as the lender in this example, and the left-hand side as a borrower. All of this is running on a local Ganache blockchain that's connected to my computer. And we're going to quickly run through a flow where we create a loan where the notional is private. We're going to settle that loan using a private stable currency, and then we're going to stream interest out of the loan and do a few more things. So the first case is just to enter in some variables here. I'm going to make a pretty absurd loan so that it will expire during this talk. The cool thing about AZTEC proofs is they all can run in the client side. I think someone alluded to it earlier, but we have a trusted setup which is going to start in the next 4 weeks. We invite everyone to take part in it. But the consequence of that trusted setup is that you don't need computationally expensive proof construction. So a proof takes about 10 milliseconds to create, and it can run on like an old Android phone in the web browser. It can run anywhere, basically. So as soon as I create this, we can go over to the other side and we see...
Just one request, could you zoom in a bit?
Yeah. It may mess up the UI, but we'll have to deal with that. So here then on the right hand side, the contrast's a little bit off on this, so you can't see the lines around this. But what we've done is we've created a loan where the notional is private. You could also make some of these variables private as well, but in this simple example, we've just made the notional private and the rest is public. So the lender here, who's originating the loan, can obviously see the notional, and they have access to decrypt that balance. And on the left-hand side, a potential borrower doesn't have access, and on-chain, all they would see when that loan was created was the public terms, which are the interest rate and the duration, but they wouldn't be able to decrypt the AZTEC note that represents 100,000 DAI in this case. So then they're able to submit a viewing request. This example dApp obviously doesn't have like the right UI that would be used in a bank, but this would happen kind of for a bank origination process. Like they would go out, do a roadshow, and get potential lenders, and as a result of that, they would be able to grant lenders access, like so. So we can see here that we can approve a certain account to view the loan's notional, and as soon as we do that, the loan will move to approved loans, and they can then decrypt the balance. You can also revoke that at certain points in the future if you want to. So it's quite good, the level of permissioning you can get with AZTEC. So the next step, if the lender here is happy with the terms and the amount, they can decide to settle the loan. So when we created the loan, we only used one AZTEC proof, which was the mint proof. So we minted a private AZTEC asset with an AZTEC note worth 100,000 DAI in this case. It's not actually DAI, but it's 100,000 units which are going to be sold for DAI. So when we come to settle the loan, we're going to swap those 100,000 loan units for DAI. And in this example, there's no discount, so it's going to be a one-to-one price. But the swap proof enables you to kind of do any arbitrary pricing. So we could swap that for 50,000 DAI or 200,000 DAI if the loan's gone up or down in value. So when we do this, because this is a dev environment, there's a contract on my computer that will give me 100,000 DAI, and I'm going to convert that into AZTEC form to make it private, and then we'll do the swap. So that's why there's a few things going on here. So yeah, you don't have enough balance, so here's some free tokens. So as soon as that has settled, what's actually happened under the hood is the note which represents the loan's notional has been transferred from the lender to the borrower. And atomically, we've swapped in the same transaction an AZTEC note that's worth 100,000 DAI. And as soon as that's happened, instead of the loan notional DAI note being owned by the borrower, it's actually owned by the smart contract which controls the loan. And that means you can do some really interesting things. It means that you can use that payment to allow the lender to withdraw some funds if they have cash flow needs or they're going to buy something with the loan. But it also means that the borrower can, the lender can stream interest out of the loan as it accrues. So because we did a loan here with a very high interest rate and short maturity, we can see the number that's going up here is the total accrued interest up to the last second. And we can withdraw interest in real time from the loan without needing approval from the lender. So the borrower, sorry. Due to some of the quirks with Solidity and it only being down to the nearest second, you can't always withdraw the amount you want, but this is just to illustrate that interest payments no longer have to be done quarterly or annually. They can be done in real time, which alleviates some of the need for a loan agent in these assets. The next thing you can do is if the borrower here decides to be an irresponsible borrower and withdraw all of the loan, the loan is technically, as of the last second, in default because there's not enough interest in the interest account to allow the borrower to withdraw interest, allow the lender to withdraw interest in real time. In practice, you wouldn't want to make this granular because it would be quite annoying for the borrower to kind of have to keep this topped up. But what this means is that the blockchain can prove information about the balance of the interest account without revealing who the owner of the loan is, how much the loan is, and how much interest is meant to have been paid. And you can do some very interesting things with that. So it enables you to allow the blockchain to validate that a loan is in default, and if there's any associated collateral with that, transfer it to the borrower without having to go through the courts. So you can now create a smart contract that allows you to have what we call programmatic default. So ahead of time, the borrower and the lender can agree to terms of what's going to happen when the loan defaults, and any collateral that's meant to transfer as a result, as long as it's on chain, can be moved by the same smart contract call. So a practical example of this is in the loan space. Usually when a loan is defaulting, there's a whitelist, and the whitelist disappears when the loan's in default. So a standard loan is only allowed to be owned by a few select lenders, but if the loan moves into kind of defaulting, the whitelist becomes open to anybody. So you'd be able to relax the permissions on trading inside the smart contract without having to go through the courts or involve any third parties. It would just be up to the borrowers to say, Mark loan is default, and the smart contract under the hood is going to validate a series of AZTEC proofs that prove that the loan is defaulting, and as a result, it will remove the permission checks that enable enable the contract to limit who can own the loan. So now the loan can be owned by any debt fund as opposed to the initial lenders, which is quite useful, I think, and it means that if you extend that to collateral such as buildings or assets, if those have been tokenized on chain as well, the title deeds can be transferred without ever having to go through a court process, which saves considerable legal fees. So that's kind of it for the demo. I can now spend the rest of the time, I think, helping people get set up if they've got issues cloning this, or I can dive into kind of talking through the code and what's actually going on under the hood. I'll really open it up to you guys of what you think will be most useful.
Question?
Yeah.
So what is kind of pre-existing support for NFTs?
So It depends what you want to do with an NFT. So the NFT has a unit of one, so everyone knows kind of what the notional is. So if you want to tokenize and say you have a particularly valuable CryptoKitty and you want to tokenize interest in that CryptoKitty, you could do that with AZTEC, but there's not much point in just having an NFT inside AZTEC unless you're trying to obscure what the NFT is. Does that make sense? So you could issue an AZTEC note whose value represents the ID of an NFT, and you could hide that from someone, so you could hide what was being passed around. But there's less use in kind of just having an NFT inside AZTEC unless you're buying, selling, or trying to split it up. So does that answer your question?
I think so, yes.
Yeah. What was the use case? I may be able to...
No use case other than just trying to understand what's possible with kind of the ZKB protocol you guys have.
So, I mean, I'd add to that then that we primarily focus on confidentiality right now. So anything that's obscuring balances in calculations as opposed to hiding the receiver or the sender. We have some updates coming in 2020 that will help make the protocol anonymous, but for most real-world assets, you know who your counterparty is. You have to do KYC. So the real value is obscuring balances and confidentiality rather than doing things for illicit purposes such as tax evasion. So anonymity is less important.
One more question, if I may.
Yep.
More general interest. If I were to, as a lender, originate a note for, say, 100,000 units of DAI or whatever, could you have borrowers draw smaller amounts against that, or would they need to kind of would the entire note need to be matched, or could you match multiple?
Yep. So under the hood here, we built this so that the loan notional note represents 100,000 DAI, but you could have 15 lenders and you could have them over time buy pieces of the loan, and all you'd have to do is each time prove that the amount that was being bought was less than the total remaining sum of the loan. So yeah, you can do things like that, like a loan auction over time or something.
Awesome, thanks.
Cool.
Can you selectively choose the actors or addresses with who you can reveal the amounts or whole details?
Yep. So every AZTEC note has a viewing key. So by default, the note owner is the only person who can view the balance of a particular note. But you can encrypt that viewing key and share it with a regulator, with any party that needs access to a particular note. So you can create a UI that has kind of permissioned access to loans or certain balances if you need to.
Who is generating that viewing key? Is it like my view key? Does the viewing key corresponds to my personal key?
It comes from your private key. Yeah. So it just uses the Diffie-Hellman secret sharing, and you take an identifier for the note and your private key, and you can generate viewing keys.
So if I would like to have, let's say, if I will have different loans and don't want to reveal all of them, then I will need to use several accounts, different accounts. Yeah, and
so you're familiar with stealth addresses? They're used on Monero. So the whole protocol is compatible with stealth addresses. So if you wanted to, you could generate an untraceable account for every transaction using stealth addresses. So there's the person who sends the proof to the blockchain to be validated. So in this case, the loan origination proof. So when we created this loan, the person who sends that proof to the blockchain doesn't need to be a counterparty in the transaction. So I could be doing a bilateral loan with you, and I could get someone else to relay it to the blockchain, which is where like a dApp would come in. Or you could make a decentralized relaying service that would do that.
Okay, so with the stealth addresses, you can anonymize the authors of the transactions?
Yeah. The only issue with stealth addresses today is none of the kind of mainstream wallets support them. So Ledger, none of the hardware wallets or MetaMask have a good support mechanism for stealth addresses. But if you're building kind of a more centralized consortium project, you're probably going to be building a custody solution anyway, and you could just implement the stealth address protocol.
Is there any limitation? Like so I guess that there is a pool of the stealth addresses. and you probably can't control who is.
So the way that stealth addresses work is you have like a key that's public. So you would have a key associated with your master account, and I can generate an account for you in a non-interactive way that you can claim, and you can't link the two accounts. So I would look you up as the lender and be like, okay, I want to create a loan for that person. I would generate a stealth address account for them, and their private key of their master account can always generate the private key associated with the stealth address account. So you have to test lots of transactions, but you can do it in a way that is non-interactive. And
okay, so there is no pool.
There's no limit. So it's just like you can keep deriving stealth addresses like 2 to the 256 on Ethereum, I think.
Okay, so basically everything is private, but even the origination of the.
But the protocol itself is doing nothing with anonymity. It's just the fact that you can use stealth addresses.
Right, okay.
In 2020, we will have. So you'll still be able to see on-chain if you have like a loan contract, addresses interacting with that contract. So you'll be able to kind of see trading activity on a loan potentially, but you wouldn't be able to see who's interacting. And in 2020, we'll have some updates that you won't even be able to see which contracts are being called. So you'll be able to hide more of the logic and the transaction graph. But that's coming next year.
For the underlying cryptography, what's the benefit? I mean, as far as I know, you are using some custom mechanism, right?
So we use Sigma
Sigma
protocols.
Yes.
Yeah, so it's like an earlier technology to ZK snarks, but it means that it's simpler and more expressive. So it's not custom cryptography. It just is it's lots of old cryptographic primitives that have been assembled in a new way on Ethereum.
Right. Why you did? I mean, what was the motivation for that rather than just using snarks?
So when we first started, and still the case today, the snark proof construction time is several minutes, and it's even more for a complicated snark like a loan. And we don't think that is tenable for most applications. We think if you're going to have kind of a proper permissioning system where like you have members of like a bank with different tiered access to a system, you can't outsource proof construction to like a centralized server because you defeat the whole purpose of
I thought that
doing
with
it.
the sapling, they were like.
Sorry?
I thought that they decreased it with sapling by an order of magnitude.
Yeah, I think it's so you can have.
ago.
I think with Groff 16 you can have pre-image and proof constructions about 30 seconds in the browser for like a simple snark. But as you add more gates to the snark, it gets more complicated. So that was one of the reasons, and the second reason was currently. When we launched the initial protocol, snarks couldn't communicate with each other, but our CTO just published a paper last week called Plonk, which is a universal snark, which allows snark circuits to communicate with one another. So when we release that in 2020, we'll be able to have the same benefits that AZTEC enjoys today, but in a snark-based system, which will be more expressive.
So are we going to provide, to have another iteration of
Yes,
the solution based on the snarks and the...
Yeah, so the idea is that the same cryptography engine on chain will now be able to validate snark proofs. You'll be able to upgrade your assets if you want extra functionality.
Okay, so that will be like a new client.
Not a new
for
client.
the engine.
It will use all the same stuff. It will just the cryptography will be different under the hood. So the goal is the proof construction API will get added to now construct snark proofs, and the on-chain validators will publish some new validators.
Mm-hmm. And performance-wise?
Today, the proof construction is still 1 to 2 minutes, I think, but you can be for the snark. Yeah, and gas costs are about the same as a Groff 16, so it's about 500,000 to 800,000 gas, but it will come down.
Okay, so similar.
Similar, but you can be a lot more expressive. So one of the limitations with AZTEC 1.0 is that the more notes you put in a transaction, the higher the gas cost. So each additional note in a transaction adds about 100,000 gas. So if you have a standard transaction is 4 notes, and if you want to have 40 notes in a transaction, you start to get close to the block gas limit.
Because now if you do any operations of your loan,
yeah,
you will need to break the notes into
Yeah, so if you want to say you have a high frequency trading loan,
Yes.
you can't do that with AZTEC 1.0, but you can do it with a syndicated loan. But inside of Snark, you can validate 10,000 transactions in one Snark, so you kind of get rid of that limit.
I see. Did you guys also look at the, what was Microsoft? They published also papers, Spartan?
I haven't looked at it, but I'm sure Zach has. Yeah.
Okay,
So.
it was like a few months ago, and they were like getting with another approach with Snarks
Okay.
to have like implementation which will not require trusted setup.
So the Plonk Snark that Zach created, we created it as an iteration of Sonic, which uses a universal CRS. So it still requires a trusted setup, but anyone can add to it. So normally when you have a trusted setup, it's kind of finite. You do the ceremony and then once, but in Sonic, you can add to it over time. So if you don't trust the trusted setup, you can just add your own transcript to it, and all the old transcripts are still valid. So it means that the setup gets better over time, and it theoretically.
Oh, really? Does it work? So you can change the global variable for.
Yes, you can. The CRS is universal, basically,
and still decrypt the.
Yeah. So you have to.
Old.
This is a bit over my head in terms of cryptography, but that's what the latest paper proves. So, but it's going to probably be about 6 to 9 months of actual coding to implement it on Ethereum. So.
6, 8 months? Why so long?
Well, we're a small team, and it's complicated. To build the whole proving system and proof construction is complex. So.
That's everything in Solidity. That's everything in Solidity.
We don't use Solidity, we use inline assembly because Solidity is too gas inefficient. So if you actually look under the hood at the protocol contracts,
you were developing this half thing.
Yeah, so it takes a long time to write the code because you're using kind of opcodes rather than a language.
And are you planning to port this to another blockchain?
It's fully compatible with any WASM blockchain, but our view today is that we kind of want to have mainnet be the best use case for this because we believe in public blockchains. We have a licensing model where banks or consortiums can deploy to private chains if they want to. We just kind of view that mainnet as being the sole arbiter of truth and consensus. So our view is mainnet will win out over time, but if you want to deploy it to Quorum or any other Ethereum compatible chain, you can. You'll just need a license from us. The license only is open source for mainnet.
Okay.
Yeah.
But if I would rewrite it by my own in another language, I mean, what is the permissions of that license?
Our proof construction is fully open source, but our validator contracts are copyrighted, so you would still run into some issues there.
Okay, I'm not a licensed expert.
So, yeah. But we can talk. I mean, our view is that we're very happy for people to experiment on private chains and do stuff on private chains. If that's the testing ground they need to get to mainnet, then we think it's a good, safe environment.
But if I would like to, let's say, use it on Tezos or Eternity?
We're considering deploying our own kind of ACE contracts to those blockchains, but Ethereum is our main bet today. So I think we'd either talk to you and be like, okay, we'll also deploy that and we'll have the same charging model, or we'd come up with a licensing agreement. But for now, we're just focused on launching on Ethereum mainnet because that's where we see the largest amount of consensus capital around the miners. Anyone else? I think we're out of time, so. Yeah, that's it. If anyone's got any coding questions, I'm going to be around all day, so I can dive in.
Do I need Docker installed?
You do need Docker Hub, yeah. So you just need Docker for Mac if you're on a Mac, and then the package will run.
Why need the Docker?
The way that the this front end works is it indexes events from the blockchain. If you're on mainnet, you wouldn't need Docker. It's just this all runs on a local Ganache blockchain, so you need Docker to run all the stuff we use to index the events. It's just faster. So, and it means that you can run it on loads of different laptops without having setup issues, hopefully.
So what are you using for indexing?
There's
local database?
There's GraphQL is a package called the Graph Protocol, which has some open source indexing software, and you index event logs. I'll run you through it afterwards because I think I've got to go now. So let's catch up afterwards. Any other questions? Great. Hopefully that was useful. So, and thanks for coming.
Thank you.